Today we're going to look at exponential functions, growth and decay. So when we're looking at this, the equation that we're going to be working with is right up here at the top of our paper, and it's y equals a, then parentheses 1 plus or minus r raised to the x power. Okay, so in our first example, a car's value decreases 15% each year you own it. Imagine you purchase a new Camaro for $38,000. What is the value of the car after 10 years? So this breaks it down for us that we want to start off with our starting amount. Well, that was the purchase price of our Camaro, which is $38,000. So our starting amount is $38,000. Then we want to look at our percent as a decimal. So I look back for where we see a percent, and it's at 15%. 15% as a decimal is 0.15. Then we want to know whether it's increasing or decreasing, because that will determine whether we're doing 1 plus our rate as a decimal or 1 minus the rate as a decimal. So we look back and it tells us that the car's value decreases. So we are decreasing, which means we are going to do 1 minus. Okay, so our rate is going to be 1 minus 0.15, and that is 0.85. So now our equation, we can plug in our A, which is our starting amount. So y equals 38,000. Then in parentheses, our 1 minus r is 0.85, so 0.85. And then we can raise to the x power. When we're looking for the value after 10 years, we'll do 38,000 times 0.85 raised to the 10th power. And when we do that and plug it into our calculators, we will get 7,481 and 23 cents. $7,481.23. All right. And that's all that we have to do with that first example. So example 2, the population of Weatherford is growing. So before we were looking for the term decreasing, this time we want to look for this growing. And it's at a rate of 12% per year. If the current population is 28,453 people, so that's our starting amount, how many people will be in Weatherford when you graduate college 7 years from now? So our starting amount is our 28,453. Our percent was 12 as a decimal, that's 0.12. We are growing, so that is increasing. So we'll do 1 plus our percentage rate. So to find our rate, we'll do 1 plus 0.12, and that will equal 1.12. Then our equation is y equals 28,453 times 1.12 raised to the x power. So when we're looking for our population after 7 years, we'll do 28,453 times 1.12 raised to the 7th power. And when we do that, we will get 62,900.52. But can we have 0.52 of a person? Because these are people that we're talking about. We cannot have a decimal or a fraction of a person. So we will cross that out, and the population after 7 years should be 62,900 people. Example 3. I bought a rare gold coin, excuse me, that increases in value 21% each year. I paid $32,924.36 for the coin. What will that value of the coin be when I retire 32 years from now? So our starting amount is our $32,924.36. Our percent was 21, so percent as a decimal is 0.21. We are increasing, so it's 1 plus. Our rate we can find as 1 plus 0.21, which is 1.21. So our equation is y equals our starting amount, 32,924.36, times our rate, 1.21, raised to the x power. And in this case, our x we're going to plug in as 32, so $32,924.36 times 1.21 raised to the 32nd power will get us 14,677,402.08. I'll take it. Okay, so our next example, your new iPhone will lose 23% of its value each year after you bought it. If your mom paid $949 for the phone, so $949 is our starting amount. We're losing 23%, so that's decreasing. What will the phone be worth when you graduate in 3 years? So our starting amount is our $949. Our percent as a decimal, 23% is 0.23. We are decreasing. We're losing value. So 1 minus 0.23 will give us 0.77. So our equation is y equals 949 times 0.77 raised to the x power. Then our value after 32 years is what it's asking us for now. We'll do 949 times 0.77 raised to the 32nd. And when we plug that into our calculator, that phone will be worth a whopping 22 cents. Challenge. This does not mean it's optional. You need to still go through this. It's your birthday. Your favorite cousin gives you $1,000. That's a great cousin. You're smart, so you decide to save it for a few years instead of spending it on something silly right now. You go to the bank and they give you 2 options. Option 1, you can invest your $1,000 into an account that pays a 5% yearly interest rate. Option 2, you can invest your $1,000 into an account that pays a 2% semi-annual interest rate. While option 1 has a higher percentage, option 2 accrues interest more often. So we want to fill out the tables below to see which is the better investment after 10 years. So our starting amount is $1,000. That's going to be the same for option 1 and option 2. Our rate for option 1, we are increasing, so it's 1 plus 5% is 0.05. So that rate will be 1.05, which means our equation is y equals 1,000 times 1.05 raised to the x power. To find the value after 10 years, we will plug in 10 for our x as our exponent. When we plug that into our calculators, we will have $1,628.89. Okay. Then for option 2, again, our starting amount is $1,000. Our rate, we are still increasing. It's going to be 1 plus, it was 2% for option 2. So 1 plus 0.02, which will give me 1.02. Then our equation is y equals 1,000 times 1.02 raised to the x. Then our value after 10 years. Now remember, our option 2 had a semi-annual interest rate, which means that it occurs interest more often. If it's semi-annual, that means it's going to accrue interest twice as often, so 2 times per year. So our value after 10 years, we need to multiply 10 times 2 to get our x value. So 1,000 times 1.02 raised to the 20th power will get us $1,485.95. So now we want to write a complete sentence explaining which is the better option and why using the information you found above. So we could say, even though option 2 pays twice as often, option 1 makes the most at 10 years. Okay. There we have a complete sentence that explains it using the information that we found.